So it's 5 p.m. We got a packed crowd here. So I'll try to keep it short and sweet. I have 50 minutes, but I'm going to finish long before that. So I'm Andrew. I'm the co-founder and CEO of Criticism. We do mobile app performance monitoring. I'm going to talk about performance and why it's important. Why are we qualified to talk about this? We're on over 1 billion devices. We operate at a very large scale. We work with some of the largest companies across verticals and industries, companies like Yahoo, eBay, Netflix, Home Depot, AT&T, et cetera. And basically what we do is we have an agent that is embedded into a mobile app, and it sends off real-time diagnostic data about performance issues. So, if your app is slow or laggy or crashing, maybe transactions are dropping, companies leverage our data to be able to understand what the business impact is, how many customers are affected, and they take our data, do a root cause analysis so they can quickly turn around a fix. As you all know, mobile is growing by leaps and bounds. There's a great presentation by Benedict Evans at Andreessen. I encourage you to check it out. It's called Mobile's Eating the World. And, and all the various metrics show that, mobile, smartphones, tablets, et cetera, skyrocketing, PCs relatively flat or declining, including usage. If you look at usage of desktop web versus mobile apps, actually more time is now spent in apps than on traditional web. So what that means is, as a percentage of mind share and revenue, more and more of your customers are moving onto this platform. Including, one example, one vertical, retail. This is estimates for the current retail market on mobile. And actually, some of the surveys show that over half of revenue now goes through a mobile channel, half of e-commerce revenue, I should say. And in a few years, what you'll see is that mobile will actually overtake traditional brick and mortar retail in terms of revenue that's being driven through those channels. Now, here's an example of a few companies that have done especially well, innovating and moving on to this channel. A few years ago, when we launched the company around the summer of 2011, there was really that gold rush to get users and to monetize. And you had two things that happened. One was you had brand new businesses emerge, like Rovio and Angry Birds. But you also had companies like, a few of the ones you see up here start to call themselves mobile-first companies. And, you can see by some of the latest stats that those companies that were quick to make that transition have been fairly successful. Facebook, I believe their stock went up about 3x since. After the IPO, it dropped. They announced their mobile revenues, and it's since skyrocketed from there. eBay's gone up about 138% in the past 5 years, largely driven by their progress on mobile. And this is a lot of people think of consumer-facing apps when you talk about mobility, but look at someone like Starbucks, where they're moving more of their in-store transactions onto mobile apps. You shop at a place like Urban Outfitters, for example. Their point-of-sale systems are through smartphones and tablets. Their inventory management. In fact, if you go ahead and return a shirt to their store, they'll actually take a smartphone and hook it up to a printer and reprint the price tag right there. So literally every business function is also being moved onto these platforms, in addition to that mind share from the consumers. But it's important that as more of your consumers and revenues being driven through these channels, that you take care to make sure that there aren't performance issues, because those can lead to many problems that I'll get into. These are some examples of performance problems that we often see among our customers. I get the question a lot of, well, what is the number one issue? I mean, there's a lot of things across the board. Kind of the hair on fire problem that you all notice right away are, of course, crashes, because the application just goes away. A lot of those errors can actually be caused by network failures, by bad data or connection types going between Wi-Fi and cellular, for example. Transactions on mobile are also different than, say, on the web. A lot of, say, server monitoring companies would look at a transaction as a web service call, where on mobile it's really you have to look at it as a set of user interactions that lead to a business outcome. And it doesn't have to be monetary. Users logging in, registration, sending a snap if you're Snapchat. Whatever the important workflows are, you need to be sure to optimize those and make sure that not only are they working, but that they're working within the constraints you expect. If it's taking 10 minutes to complete something you expected to take 2 minutes, then there's obviously an issue there. The number one cause of performance problems are bad ratings and reviews in the App Store. And consumers have a lot of choice. There's over 1 million apps out there. If it's not working, they'll move on to the next one. And it's not just that gaming app that they'll drop and move on. It's, in this case, this consumer is saying, you know what, I'm done with my brokerage. I'm going to switch to TD Ameritrade. And that's not an unheard of scenario. In fact, Google did a survey not too long ago that showed that 1 in 6 consumers actually switched banks because of a poor mobile app experience. So if they're willing to switch to a different bank, they're willing to switch to whatever your business is providing. Of course, if you're processing transactions through apps, there's a huge amount of revenue at stake. We just went over some of those numbers. Your brand is at risk. And of course, if you don't have visibility into these performance problems, you have to go by these reviews, and most consumers just aren't knowledgeable enough to be able to describe the problem that they're having. I used to develop mobile apps myself, and when our apps had problems, we'd try to get in touch, and the consumer would say something like, my Google phone isn't working. And obviously that's not enough to go back and recreate the problem. So why is this so difficult? You're all familiar with the fragmentation problems, thousands of Android devices. Even in iOS, Apple releases updates fairly frequently. You've seen since iOS 8, many fixes have published. There's over, it says 691, I believe it's over 800 when you include all the virtual network operators, and carriers can certainly cause problems, and I'll go into a few examples of those. Many apps can depend on many disparate cloud services, and any one of those cloud services can cause performance degradation. So when you add it all up, over 100 million permutations, impossible to test every possible use case. Of course, we encourage you to test, but at the end of the day, even if you could perfectly QA that app, the next day that new Samsung device comes out, and suddenly you see some issues inevitably crop up. So here are 3 areas, and I'm just going to dive into responsiveness. If you're depending on those many disparate cloud services, you better be sure that you've architected your app in a way not to block or wait for, say, any of those more flaky services to complete. Going back to another Google survey, this is showing consumers what the consumer impact is of poor responsiveness. And in this case, there's an expectation that less than half a second, you better provide some kind of feedback to the consumer. And the reality is that on average, cloud services, over half of them take about half a second or longer to complete. So if you're blocking on those, then you will begin to lose users. Our data shows that on average, the average mobile app can depend on over 6 different APIs. These can be social providers, authentication providers, really any type of cloud service that the app is interacting with. Our data also, I mentioned over half of them are about half a second. They also can experience many errors. In fact, I have a list of the top cloud services along with their error rates and latency. And by the way, all this data we've published in a benchmark report. If you go to criticism.com, you can find it there. You can also go to data.criticism.com, and you'll be able to find many other benchmarks that we're starting to publish on there, including we have an upcoming Lollipop-specific announcement that we'll make on there. We get the question a lot of, well, what can I do if Facebook's not working? Or any other cloud provider that you're leveraging. I mean, in the trivial case, you need to account for complete failures, and your app needs to be able to respond to that. But the question is if you're actually, how you're actually using or abusing those APIs. It may work great to get someone's entire friends list in San Francisco, but you go out to Topeka, Kansas, and suddenly there's a lot of latency issues. So maybe in that case, you would decide to just get their friends in a specific location. So you actually need to think about how you're actually using these APIs. So just a few real-world examples. We had, you may think that if you're just sitting on your server looking at responses coming in, that will tell you the whole story. I can tell you it's not true. We had a major retailer that sells things like patio furniture and refrigerators. They actually discovered they were dropping 30 minutes of transactions every day. You can imagine what the revenue risk there was. And what they discovered was they had configured their firewall to block an IP address range from Amazon Web Services because that's where they discovered a lot of denial of service attacks were originating. Well, guess what Amazon did? They went ahead and they sold that IP block to AT&T, and then suddenly AT&T customers couldn't access that retailer's service through their app. Their firewall was doing its job. All the lights were green on the server, but from the consumer, from the mobile end user experience perspective, they weren't able to complete any of those transactions. Some other quick examples. We've seen problems where a different retailer was delivering very large product images in their catalog. They weren't cleaning up those images correctly. Eventually, they had out-of-memory errors, which is actually really bad if you think about it. That means that users who are spending a lot of time browsing the catalog, adding items to their cart, the more they did that, the more likely that the app would fail. Okay, now I'm going to talk a little bit about uptime or availability. There's an expectation on the web of multiple nines worth of uptime. And surprisingly, on mobile, the average is about 98%. Well, actually, I bet the average is even higher. Our data is from customers that are leveraging our products, and they care about their performance. But out of that, 98%. So just to put that in perspective, this is an example of what the revenue impact would be on a company. And actually, I'll give you a more specific example, a public example. Groupon, they told us that they process something like $100,000 an hour. Right? So, in the case of 14 hours worth of downtime, it's actually not too far away from this. It would be about 1.4 million of revenue risk there. So again, here's some of our averages. I mentioned 2% is about what we see there. And we've also broken this out by platform. So here are, it's actually within a relatively similar range across the different platform types. This is actually a lot better than what we've seen in the past. In the past, some of the older platforms, especially Honeycomb, have huge amounts of failure rates. But the platform owners, both Google and Apple, have been doing a good job about pushing out updates fairly quickly. You can see all the different point updates there, and along the way they patch issues. Here's on the iOS side. We've all seen the news around iOS 8, many of the changes that they've made. Actually, many of those changes, something that Google has had to deal with for a long time, which is varying screen sizes, being apps that can fit, say, that new iPhone 6 Plus. So that, along with many other changes they made, caused elevated error rates and caused all those patches that you've seen since then, which have helped. And here I have the data broken out by device as well. Again, pretty similar across the various devices. Here's a look by category. Now, as you'd expect, the devices that push the limits, the apps that push the limits, the very graphic-intensive, CPU-intensive type applications have elevated error rates. Also, as expected, anyone that's processing any type of monetary transactions, it really matters for them to make sure that the uptime, is close to 100% as possible. Just a few other real-world examples here. We had one of the largest social, I guess it is a social network in the globe. They actually discovered they had a problem on Motorola devices. They didn't even have a Motorola device in their office to test with. I believe it was a camera driver issue. And you can't really get that visibility unless you're actually investing in monitoring your performance. Another Groupon example, they had an issue where Vodafone in the UK pushed out an Android update to all their devices before other carriers, and sure enough, that caused issues. So just going along that location theme, it can be very hard to diagnose geo-performance related issues. Here's actually some of our data related to carrier performance across the globe. In this case, some of the countries that you'd expect are showing slower performance. Korea is the #1 in terms of performance, which is great since we're at the Samsung Developer Conference. I did not change that. And here's a view in terms of Wi-Fi performance across the globe. In this case, Nigeria is the worst performing. And so the point is, if you're developing an app, many apps are just inherently global in nature. You need to understand that if you're delivering a very high fidelity experience, that may not work in many areas across the globe. So if you're a video sharing or video viewing application, maybe you switch over to images or some kind of lower fidelity experience, depending on where the application is being used. Or you choose to invest in additional CDNs or capabilities. But you can't do this unless you have that visibility into what your latencies look like, your HTTP error rates, crashes, et cetera. So here's another real-world example. So this is actually a view from our product, a geo-performance view. There was a major payments provider that launched their chip and pin product in the UK. And they spent about 4 months of engineering time trying to diagnose performance problems. Finally figured out that it was a physical steel bridge that was blocking their signal. Something that's impossible to test for in a lab, but something that you're able to detect looking at this kind of data. They weren't actually using our product at the time. They took one look at this and said, "Where were you guys 4 months ago?" Here's just drilling in even more down to the county level. Just a few other examples. We've seen a lot of problems with the firewall in China. There was a major name in the sporting industry that launched in China, and it ended up a lot of their connections were blocked. Some code that they didn't test was executed, and actually led to a lot of crashes for them. A lot of companies that depend on cellular service have run into issues when launching across different cities. In particular, there was a courier service in San Francisco that leveraged AT&T. They launched in New York City, saw a lot of connection drops and latency problems, eventually made the business decision to switch to Verizon after looking at this type of data. All right, so a few names I can mention that we've worked closely with. Urban Outfitters is one of them. They have improved their performance dramatically. They saw about a 7x increase. We've seen many of our customers also jump from, say, 2 to 4 stars as a result of investing in fixing these performance problems and paying attention to them. And you can imagine for any retailer or anyone processing any type of monetary transactions what the impact was. And then you look at IoT, more and more connected devices coming out into the marketplace. You definitely see the worlds converging where really what's the difference between, say, a Surface tablet with a keyboard and your laptop? There is none. We see apps coming up everywhere, the mobile platforms taking over traditional platforms. And where you see an app no longer has to necessarily be a smartphone or a tablet. However, that adds complexity because connected devices, there's about an order of magnitude more of those than smartphones and tablets. You also start to deal with different connection types. You're not just Wi-Fi or cellular, it could be Bluetooth or another communication protocol that you're leveraging. Another, and actually in this example, we see you have a smartphone or tablet as the hub that's controlling these connected devices, but you also have devices that are isolated that can run on their own. In this case, this company develops Android-based exercise bikes. So, they have a display, you can pedal, and you're going through the Tour de France, you can see the mountains. But they're interesting because not only are we helping them power their displays, but they actually modified the Android OS, included our performance monitoring software in the operating system layer because that's where they saw a lot of their sensor failures originating. So what should you do about this? I mean, at a high level, you need to understand the high-level trends in your app. What certain platforms are working better than others. You may decide that, I can't support every OS or every device. There's a certain legacy set of configurations that are causing all of our support tickets, all of our one-star reviews. You need to draw that line in the sand and say, we're not going to support these anymore. Once you can identify the issues, you need to be able to prioritize them, know how many users are impacted, or what the business impact is. You necessarily don't want to chase every issue, of course. But if you're just looking at how many users are affected, you'd also lose out on something like, let's say 99% of your users couldn't update their profile information, but 1% couldn't transfer money. You may actually want to focus on the 1% there. So you need to understand what the business impact is as you look at these performance problems. And I mentioned before, obviously paying attention to the most important flows in your application is important. And it's not just a single screen or a web page in the web world. It encompasses many screens, many events. The user could background and foreground the app. They could receive a call while they're taking these actions. These are all things that you need to account for. And I jumped ahead a little bit, but here's a view into, say, identifying what the revenue risk is of your mobile application, helping you prioritize actually what you should be looking at, what you should fix. So I tried to run through this. I realize it's getting late. I just wanted to let you all know how important this stuff is and what kind of impact it can have on your application. So that's it. I'm happy to take any questions and also talk to you afterwards. OK, thanks. Let's see. Oh, and I was told to leave this screen up. Actually, I'm not sure. I think they might be recording it. They're probably going to post the videos, but to be honest, I'm not sure. Yeah.
Do you guys get involved in assessing the revenue impact?
We do, because we let you define what those important workflows are in the app, and you can attach either a default value or the actual value through the SDK that we provide. And that way, we can tie those workflows to the performance problems that we're also monitoring. So we can tell you what, say, the revenue at risk is of a certain performance issue.
How do you guys gauge that? I saw these kinds of numbers way back when from Amazon. You're talking about every second of latency is equal to $150,000 of lost revenue, these kinds of things. I mean, how do you gauge that?
Well, for one thing, we've, in our product itself, we will just tell you the revenue at risk. There's all the time we see a consumer will attempt a transaction, it'll fail, they'll attempt it again, it'll fail again. At that point, the company needs to reach out and make sure they can help them complete that. But there's also been a lot of studies done. There was a Google study on, I forgot the name of it. Let's see. It was Time to Glass, I believe was the name of it. Let's go back here. Where they basically showed, they did a test on consumer reaction to performance issues. Oh, here it is. And it's just been shown that, eventually, call it at, the 1 second mark, they'll start to context switch and eventually just abandon the application.
Right. So in the case of a failure, right? I mean, I can understand that because you can gauge it and say, okay, user tried to buy something, it failed once, they tried to do it again, it failed twice, and it failed the third time, and they just went away, right? So I get that piece.
Mm-hmm.
But like in 1 second, it meant what? That the user, it took 4 seconds versus 5 seconds to conclude a transaction, and when it reached 5 seconds, that's the point where they left, right?
In this case, it's the render time. So, they say they tapped a button. If it takes longer than, say, a second, you start to lose the user.
Right. And so this is a very generic marker.
Right.
Right. So if you apply this towards e-commerce versus social network or file download or whatnot, then you're going to get 3 different responses. How do I personalize that kind of report?
You know, I think at the end of the day, what we've seen our customers at least do is they'll set their own KPI in terms of, you know, how long should this take to complete. And what you can do looking at our data at least is understand, okay, are we, you know, a standard deviation, 2 standard deviations away from what that KPI is? So you can set that, and then we would then alert you if, say, you know, a cloud service or latency issues were causing that transaction to take longer than the bar that you had set.
Right. So I understand that piece. So
Yeah.
I get that. So I guess it's really about the science behind the KPIs, and that is something that you guys don't get involved in.
You know, we are working on our transaction monitoring product launched relatively recently, so we've done a lot of benchmarks of other types of data. We will be providing some industry benchmarks on transactions as well, which should help address a lot of those issues, or those questions. Any other questions? Yep.
So are there any general rules you can tell application developers on what they should do or what they shouldn't do? Something you have seen across many applications that people do wrong?
You know, well, the first thing is, you know, it works for me, and assuming that everything's good. I think, you know, there's a few things is you need to just account. You can't depend on even some of the major cloud services that you leverage to work. You know, whether it's an ad network or you know, Twitter's API. You know, we have a lot of media companies who have to pull out their ad networks all the time, major ad networks, because they're causing serious problems. You know, I guess my advice would be, you know, yes, handle the crashes and errors first, because that is that hair on fire issue. But you can't just stop there. You know, you have to take that next step and look at your API usage, as well as hold your service providers accountable. You know, if you do notice an issue, I'm sure there's some kind of SLA that is in place. You need to go back and, you know, have that conversation. Any other questions? Great. All right, thanks.